This YouTube video is for the purpose of the explanation and testing of my OCR Computer Science A-Level NEA project, which is a portfolio generator using the Black-Litterman Allocation, as well as a prediction app using Plotly and Facebook Profit. When the user first runs the code, they will be redirected to the registration page, as they will have no existing accounts. Here, they will be able to create their first account to be able to access the other pages. Test 1 will be creating a successful account. This will have the details somebody, password will be money and more, which will be left visible, money and more, money and more. As you can see here, we have a successful registration as well as a hashed password. This has been viewed only for the sake of testing and will be removed during actual implementation. For the second test, we have to test for a duplicate username. To do this, we simply have to press the registration button once again. As you can see here, the username already exists, therefore test 2 is also complete. Test 3 will be checking whether a blank password field will allow the user to still log in. As you can see here, the user sees that the passwords do not match, meaning that this has been a successful test. Moving on to test 4 with a blank username. Again here you can see username cannot be empty. So retyping in the username, we are now able to test for if the passwords are different. So I can change this to be 2 different passwords and try registration again. As you can see, the passwords do not match, which means that test 5 is also successful. Moving on to test 6. Test 6 involves my boundary testing for my passwords. Passwords must be between 8 and 20 characters long with 1 digit and 1 uppercase letter. To test that, we will first do length testing for test 6. We'll type in the password pass123 and then pass123. As you can see, these passwords are too short and therefore we are given an erroneous message and test 6 is successful. Moving on to test 7, where our password is too long. We are able to see, and looking at this password, it is clearly over 20 digits, and therefore you can see password must be between 8 and 20 characters long. Moving on to test 8, where we can test now the character references. Typing in the password, passing it on, which is within the length requirements, but does not fulfill any other requirements. We should then still not be allowed to log in. As you can see here, password must contain at least 1 digit and 1 uppercase letter. To test the AND statement, we will type in a digit and still see if we can log in. As you can see here, this is still not appropriate, as we need both the digit and the uppercase letter. The final test for this will be testing the hashing algorithm. We'll pass in the following password, 1011, copy this in to the second level and see. As you can see here, we have successfully registered an account with the following hash key. Passing that into the SHA-256 algorithm, we can see that hashing this will give us the exact same hash key, showing that this has been a successful test. Moving on to the login functions, we are now able to save our password. So the first test would be saving with a blank password. So you can type in our somebody2 and our password, which was here. So we have now our initial values. Testing with a blank username, we are unable to log in, so test 11 is successful. Testing with a blank password would also be unsuccessful, as you can see. As you can see here, there is an incorrect password. So if I try to log in, we have an error message, meaning that test 13 is successful. Test 14 will be pressing login once with the correct details, giving me a success message. Moving on to test 15, where if I press login once more, I'm able to get redirected to the explanations page. This is where tests 16 and 17 can begin as well. Test 16 is just testing if this hyperlink works. Although this now redirects to a completely random page, as you can see,
This YouTube video is for the purpose of
if we were in the actual implementation, this screen recorded video will be added in for this YouTube hyperlink. The 17th test will be testing whether we can move to a different page, in this case portfolio generation. This has been successful, so therefore test 17 has been successful as well. Looking at the portfolio generation page, we are able to start test 18. Test 18 is entering the investment amount with a number less than 0. So we have tried minus 8.556. We're to press enter. We have the warning that the value must be greater than or equal to 0. And until we fix this error, we are unable to move on. Therefore, we can assume that test 18 is successful and we can re-enter the initialized value. Test 19 is doing the exact same thing with the risk-free rate. So setting that also to be minus 8.556. Give me the exact same error. We're unable to move on until this error has also been fixed. So test 19 has also been successful. Test 20 is entering both a start and end date in the future. So we will just move this to be 2026. And this date can just be moved to 2028, the 4th of April. As both of these dates are in the future, we can then see that we should be unable to gain any form of data whatsoever. There's no data at all available for these dates, and therefore portfolio generation cannot occur. As you can see here, no data has been fetched for the tickers, showing that test 20 has been successful. Test 21 is setting a start date that is later than the end date. We can reset the end date to today's date of the 4th of April, and we can try fetching the data. This time we will have valid data for the end date, but now there is no overlap in values between the start and end date. So this will also create an erroneous value in which we have no data whatsoever sourced from Y-Finance, and we have another error in terms of generation. As you can see here, by the fact that no data has been fetched for these tickers. Moving on to test 22. Test 22 is trying not to select the benchmark. This is not possible as I have passed in the initial ticker for the S&P 500. Therefore, it's possible to change the ticker, so for example to the FTSE 100, but it's not possible to leave this blank. Therefore, we can then move on to test 23. Test 23 is testing whether we can leave the investment amount blank. This is not possible. Every single time we try this, it just passes in the initialized value. So you can see that test 23 has been successful. Moving on to test 24, setting the investment amount as 0. This will allow for a successfully generated portfolio. The investment amount does not actually affect the portfolio parameters in any way. It's simply a recommendation in terms of the weights. So you would multiply your weight by your investment amount to see how much you would invest. As you can see here, as I still have not changed my start date back, we have no data being sourced. If I was to change it back, you can then see that the running icon in the top right corner shows that the algorithm has started to run, and we can see a successfully generated portfolio. From here, we're able to move on to test 25. Test 25 is viewing the top 10 tickers by Sharpe ratio and the top 10 by Sortino ratio. As you can see here, they are both viewable, and the only action we can do with these is to copy them. So I can copy the Sharpe ratio ones to the clipboard and paste them in, and I can do the exact same with the Sortino ratio ones if the clipboard shows up. As you can see here, we've tried it with just one ticker in this case, but you can still see that this has been a successful test. Moving on to test 26, we look at the data frames. Data frames are effectively like Streamlit's version of tables, but for elements that contain some form of data. In this case, we have the stock data preview, so the last 5 days of data for these 12 or 13 stocks. As you can see here, we cannot search by date or by ticker name. We can only search by elements. So the 3 things we can do with this is download this as a CSV file. You can see this is successful as the following icon pops up. We can search, as previously mentioned, only for elements. So let's say we are looking for 84.7 84.68, 84.68. We can see that this has been highlighted. We can also full screen and minimize full screen, showing that all possible tests with the data frame have been completed successfully. Moving on to test 27. Test 27 is viewing and doing something with the graphs. We have this first graph, which is the price series over time. So how the value of each ticker in my optimal portfolio has changed over time. The only thing we can do with the matplotlib graph is to full screen it and minimize full screen, showing that this test 27 has been completed successfully. Test 28 is about each of the buttons. This does not need to be tested in and of itself, as in the following tests we will test each button individually. Moving on to test 29, we can see that the fetch data button, as you can see here, the fetch data button is clearly functioned as we have a fully functioning portfolio. So we are able to move on to test 30, which is viewing whether the CSV button is functional. As you can see here, as we scroll through, we have the CSV button. We are able to download this and open it as an Excel file. So viewing this, we can see the top 10 tickers in our optimal portfolios. We have the count, so the number of days of data we have for this particular ticker, the mean value, standard deviation, some linear interpolation values, and then the Sharpe ratio, compound annual growth rate, and annual volatility of the portfolio as a whole. So you can see this Sharpe ratio is 1.86. We have a compound annual growth rate of around 30.4%, and annual volatility of around 19%. As you can see here, all buttons create a web refresh, which means we can move on to a different page in order to save time and move on to the next test. The next test is testing the ticker stats Sharpe portfolio button. This is a slightly more formatted version of the previous one, as it gives data for each of the individual tickers in and of themselves, not just the portfolio as a whole. So you can then scroll down to this, and we can click on ticker stats Sharpe portfolio button. Again, the page is refreshed. Now we're able to view the portfolio successfully. Pressing open file, we're able to view this. Again, we have our 10 tickers, the count, the mean value, standard deviation, minimum, 25%, 50, 75 maximum value, so our linear interpolation. But here we have different Sharpe ratios for each of the tickers, different compound annual growth rates for each of the tickers, different annual volatilities for each of the tickers, and then the weights of which these will go into the optimal Sharpe portfolio. In this way, test 31 has been successful. Finally, the last button that needs to be tested is the Save Portfolio button. This button is located all the way at the bottom of the page and allows certain variables that will be useful for future referencing to be saved as a JSON file and to the SQL database as a whole, and be viewable at any later date unless they are cleared. As you can see here, we can press the Save Portfolio button, receive a successful message, and assume that it has been saved to the Save Portfolio page here. We will do that in the next 3 tests. However, test 33 is testing for different parameters. So here we will test as a novice. So novice has 1 year of investing experience, very low risk tolerance, and a very high investing time span, along with a very low investing amount. 1500. As you can see here, our investment score is very low, and our logarithmic investment score, which is this number taken to base 10, is negative 1.1. This will allow me to find the correct threshold for this portfolio. While this portfolio renders, this would be the perfect time to do the explanation of the portfolio as a whole. Here we have the top 10 tickers by Sharpe ratio. The Sharpe ratio measures the ratio between risk and return. So these are the tickers in which the risk you take by investing into this is best valued by the return they give. Sortino ratio is very much the same, apart from the volatility focused on in the Sortino ratio is only downward volatility rather than upward. Here we have the data frame, as I mentioned, the last 5 days of stock data. We can see fluctuations over time due to market sentiment and exogenous supply side shocks, such as Trump's tariffs. You can also see the S&P 500 and its change from nearly 5,700 to now just under 5,400. Our price series, so those 12 tickers and their price changes over time. Our correlation matrix of returns. So this represents if let's say Tesla was to go up by 1%, Tesla would also go up by 1%, representing this diagonal line. There are some tickers in which there is very high correlation. So we can see Walmart and Costco, as they're in the same sector, have relatively high correlation, whereas Lilly and Nvidia have a much lower correlation as they are not related in any way. Moving on, we have the efficient frontier. We should have two separate stars for the Sharpe and Sortino ratio. The fact that we can only see one star indicates that the optimal portfolio covers both of these ratios at the same time. Here we can see the volatility is approximately 0.19 and a return of maybe 0.37. Optimal portfolios tend to be on the bottom left of the page, as moving towards the right, we take unnecessary risk for the same amount of return. So taking this portfolio, we are taking on a significant amount more risk for the same amount of return. So this would be a suboptimal portfolio. We have the Sharpe optimized portfolio. So that is the red star, which would be directly under the blue one. And we can see the splits and weights for that portfolio. The Sortino one, which is the exact same, as you can see by the stars overlapping. And then different focus points. Looking at the Sharpe portfolio, if I wanted to maximize my Sharpe ratio again. If I had my Sharpe portfolio and I wanted to optimize my Sortino ratio. Again, all of these will be the same in this case, as both the Sharpe and Sortino portfolios are the same. We have the metrics, 1.86 Sharpe ratio, a 30% compound annual growth rate, 19% volatility, beta, which represents volatility against the market as a whole, showing this is slightly less volatile than the market. Alpha, how much my portfolio beats the market by. Our Sortino ratio, the exact same as the Sharpe one, and our R squared. This is a correlation coefficient that measures the correlation of price fluctuations between my portfolio and my benchmark, in this case the S&P 500. Here we have the Sortino optimized portfolio, the exact same thing, apart from we are now focusing on the Sortino portfolio. As we can see here, we have slightly different values. However, our alpha is the same. Our beta has gone up considerably, and so was our annual volatility, as these two normally tend to be linked. We then have our formulae reference, so how each of these metrics were calculated in the mathematical sense, our buttons, and then the logarithmic investment score. So this is where the tailoring comes in for the different parameters. Here we can see our logarithmic investment score is minus 1.1. So you can see that our maximum volatility should be 0.2. Our optimal Sharpe portfolio has a value of 1.96 with the following values that I read off the efficient frontier and the data frame with the weights you need for this Sharpe portfolio. However, the portfolio with the highest return will give you a 0.38 volatility, 0.38 return for 0.2 volatility. So this would be a 38% annual growth rate. Moving on to test 34, we are now able to look at an expert's view. An expert will have many more years of experience, so 25 years of experience. They will be willing to take more risks, and they will normally invest for less time. We will have a considerable amount more money. As you can see here, our investment score is 100 and our logarithmic investment score is 2. Again, we can fetch the data. This will present very much the same results as the previous tab, apart from at the very bottom, our thresholded portfolios will be different. So as you can see, our Sharpe and Sortino ratios have been the same. We have the exact same data frames. So this is to ensure continuity across all pages, regardless of parameters. We have our S&P 500 data. We have our price series, the same correlation matrix, the exact same efficient frontier, Sharpe portfolio, Sortino portfolio, etc., etc. Normally, the page as a whole takes around 90 seconds to render. So as we patiently wait for that, we can see that the running algorithm has gone, showing that we can scroll all the way to the bottom and move to where we have a logarithmic investment score of less than or equal to 2, which we find here with a maximum volatility of 0.35. We have the exact same sharp portfolio, but for the highest return portfolio, we can get a 52% annual growth rate, but with a 33% volatility. And these are the weights you need for this. Moving on from here, we are able to go to the saved portfolios section for test 35. Moving on to this page and scrolling all the way up to the top, we can see the portfolio we saved just a couple of minutes ago. We can then see configuration. Configuration is just all the different parameters we can see. Optimization, the tickers for the sharp portfolio and the weights, the tickers for the Sortino portfolio and their weights, the dates of data sourcing, and the different metrics. These values have not been truncated, unlike the versions in the portfolio generation section. These can also be copied. If I was to copy the clipboard at the very top, go to an empty page and paste it, you can see that everything has been pasted and copied successfully. Moving back on to the page we were currently on. So this one, while I close all the other tabs. We are then able to move to test 36, which is to download this portfolio as an Excel file. This is not recommended. This portfolio is permanently here and saved on your SQL database, but for continuity, this button is also available. As this data is permanently saved, this does not cause a web refresh. And as you can see, we can download the portfolio here. Test 37, therefore, is to clear all saved portfolios. This is to ensure that there is no unnecessary clutter in this page, and we're able to clear all portfolios. So pressing this button, we see all saved portfolios are cleared. If we simply go in between pages, we can see we have no retrieved portfolios, meaning test 37 has been successful. We are now able to move on to test 38 within the stock price prediction page. We can now commence test 38 from the stock prediction app. Test 38 is running the initialized ticker here, which is Apple. Apple has had many years of consistent public stock growth since their IPO, and they have many years of data on Y Finance. So it is a good basic stock in order to start prediction. As you can see, prediction has immediately begun, and you can see that this is functional. Test 39 is to enter a slightly misspelled ticker, so APL. In this case, it autocorrects to Apple, which means that test 39 is also successful. Test 40 is testing the Great British Pound ticker. Currency is very poorly supported on Y Finance, so this has not been implemented into my program, as you can see by the fact it says no results. So test 40 is also successful. Test 41, we can see is using Pret. Pret is a privately owned company and therefore also has no publicly available shares and will therefore have no results. Therefore, for test 42, we can go back to Apple and predict the stock, meaning we're able to explain how this page works. We have the first 5 rows of data that have been sourced, so from the 1st of January 2020, and the last 5 days of stock. You can see a sharp fall in value as well as a sharp rise in the number of volume of tradable shares. We have a range slider, so this is similar to the price series in the portfolio generation page, except for we can adjust the axes in this case in order to see fluctuations in more detail or less detail. There are also more functionalities available. I can save this as a PNG file. I can zoom in and out, pan across, zoom in and out again, auto scale, reset my axes and go full screen and minimize screen. We have our forecast data. So the algorithm predicts that Apple stock will go to around 302 by this time next year. We have our trend higher upper and our trend lower. So the very highest it could reasonably be would be 364. The very lowest would be 243, which is represented by this shaded region. Here you can notice some black dots performing a trail here. These are the real values from the previous graph that allow me to help predict the stock for the future. We have our trailing and forward PE ratios, which have been taken from Y Finance, market capitalization, and our cumulative return. So if I was to buy on the 1st of January 2020 and sell today, I would have made this much percentage return. We have a simple moving average for Apple. So we have this orange curve taken every 50 days in order to plot a smoother curve for the Apple stock, which makes it more easier to perform calculus on. Bollinger Bands are used to see if the stock value moves up and down very rapidly. So near January 16th and 17th, it reached the lower Bollinger Band, which is 2 standard deviations below the normal 20 days simple moving average. And closer to February 14th, it reached the upper Bollinger Band, which is 2 standard deviations above the simple moving average. We have a stochastic oscillator. This has 2 bands at the 80th and 20th percentile, and these are used to indicate whether stock is overbought or oversold. An oversold stock indicates a sharp rise in price, as you can see, and a deeply overbought stock indicates a drop in price. This can be used to sort of predict what kind of values we will see in the next few days after seeing the stock. Again, we have the formulae reference, and then from here we're able to do test 43, which is back testing. Again, we will use Cintas as it uses very little market sentiment, and we will predict from a year ago. So we will look at today's value simply. So looking at today's value, it's around 205. If I was to predict this from a year ago, so 2024, 4th of April, predict stock, we're able to see that a year ago it was around 168, and the prediction for the future is around 209, which is still extremely accurate, taking into account all the exogenous shocks due to Trump's tariffs. Overall, this is quite accurate in my opinion. The last test on this page is viewing the save prediction button. This will allow me to save all my prediction details in a similar way to the portfolio button. So you can see this has been successful, and we can see the details have been saved successfully. We can then move on to test 45 in the saved predictions. We're able to copy all of our data into our sheet, and we can scroll through our different stats. So our ticker, how the dates, start and end dates, as well as our DS values, y-hat, so regression, upper and lower, trend, upper and lower, and we have test 46, which is the ability to save this as well as an Excel file. So as you can see, we can press this and get a successful test 46. And the final test is test 47, which is the logout function. I can press logout and be successfully logged out. And if I was to move to any page that requires a login, such as portfolio generation, I am prompted to log in or register first, showing that all tests up to test 47 have been successful. Thank you for watching this video. I hope that you've enjoyed watching it as much as I've enjoyed creating this website, and I hope that you're able to use this for some benefit of your own.